Doesn't really matter.
Yeah, there wasn't an option to upload it either.
Oh yeah, now it shows we're live streaming. Let me see if it's showing up on. Now it's on YouTube too. Good.
All right, sweet. Let's go. First YouTube stream. So we have some subs on there, so maybe some people might see it. You know, maybe one.
Yeah.
My Twitch. Let me share out my Twitch.
All right, I'm posting it on the sign X count, and I'll go post it around X.
All right, cool. Yeah, we can just share some stuff out. And then let me go to the comments. Can't post comments to some destinations. Okay, show comments on stage. Comments take the stage. Live comments from viewers will appear on screen during your stream. Okay. It looks like they show up on the right over here.
Okay.
I see a little. Do you see that little faded section on the bottom right?
Let me see. On the right cat column?
No, of the display stream that we're doing.
Oh yeah. So that should be chat.
Yeah, that's gonna be chat right there.
Dope. Right on.
Yeah, let's go. Okay, so let me share out my Twitch. Yep, that's streaming.
Why didn't it give us a thumbnail image for the live stream link? That's weird.
Oh, that is weird.
I gotta redo it. I can repost it. It's not anybody's seeing this. Let me try a different. Let me pull up the stream and then link it. Maybe I'll do it. We're live, but nobody's watching us, so it doesn't matter.
That's all right. Okay, so I'm sharing out this. What should I share out? The Twitch or the YouTube, or maybe both? I'm just gonna share both, honestly.
Okay, I know if you do more than one external link on X, it puts down in the algorithm.
Oh, no, I was gonna put two different posts.
Oh, okay, yeah, cool.
Or did you already do YouTube yours? Because I can just retweet yours.
Yeah, I did. I'm gonna delete this one because it's not showing a thumbnail image, which is weird.
Yeah, my Twitch thing doesn't show either. Oh yeah, it does. All right, so I just shared out my Twitch. If you want to retweet that, and then
you shared it on X.
Just my personal, yeah. Oh. And then go ahead. Are you on the sign X?
I am, yeah.
Okay, I would share the YouTube out there.
Yep. All right, just did.
Okay, so then I'll share that from my personal.
It's not showing a thumbnail though. It's so weird.
Hang on, let me see what it looks like.
See what I'm saying?
Hello? No, I don't see it. Hang on. Oh yeah. It's just only the link.
Yeah, which is weird.
Huh. It is really weird.
I can do a screenshot of us.
I have a banner I could send you that's for the. Oh, it's on the wrong. Oh no. Yeah, I have the banner I could send you.
I could also screenshot our stream right now. Yeah, that's fine. Send me the banner. You can upload that. That is a thumbnail image.
All right, hang on one second. Let me how do you?
Oh yeah, and it does show me looking the wrong way too. That's fantastic.
Yeah, I don't know why. It's weird.
I'm gonna flip it in the settings, see if that'll change.
No, go ahead and do whatever you want for the thumbnail. It's fine. Because I don't have it handy and I don't want to open up new stuff while we're streaming.
All right, smile at the camera. Oh wait, hold on, smile still. That should work. Okay.
Do I look crazy?
Yeah, I was half done smiling, but it's functional. It'll work.
Okay, I think we're live on Rumble. Yeah, we're live on Rumble. So I don't need to have that open anymore.
Until people are complaining about us in the comments from not talking about the subject matter, we're good to troubleshoot live.
Yeah, literally, we're just chilling, man.
Yeah,
that's how I feel about it.
Yeah, so let me edit that post and add this thumbnail.
Where does it even show like our total viewers on here? StreamYard does it? Oh, right here, 1. Okay, I see. Is that 1? Oh, that's me officially meta. On Twitch?
Oh, I don't know. Yeah, I'm watching it on YouTube, so probably view there.
I have 1 on Twitch, it says.
Yeah, we're just gonna add that. Let's do it that way for now. Okay. Repost that.
Oh, we got the bots on the stream post.
Oh shit.
Instant bot.
Okay, repost this. Share the link over here. Okay, and then on your page, you said you posted your Twitch account?
Yes, I did. Yep. On my main.
And
okay,
then,
did you just get the sign post out?
I did, yep.
Okay, cool. I'll get that shared out.
Yeah, reposted.
I'm dead. My face. I love it. All right, let me retweet that.
Let's see. And then
try. What if we paste this in a comment? Let me try that.
Yeah, I was gonna say I was gonna just paste your Twitch link in the comments of the YouTube link.
Try pasting the YouTube link just by itself as a comment and see if it brings up the thumbnail.
Okay, good thinking. Yeah, I'll try that too. I also post this here.
Oh, that's what I need here. Hang on.
Let's do this here. This here. I mean, it should auto thumbnail before I even post, which I don't see it doing, but yeah, it's still not showing a thumbnail. That's weird.
Huh, that is weird.
I don't know. I'll figure out one in the future. I mean, we got that screenshot right now, the thumbnail that comes with the initial post, so that's something that at least gives people a visual.
Okay. Yeah, that works for now. Yeah, we're good.
Yeah, I'll figure that out in the future.
Okay, so I see your retweet. Let me go on sign. Sign's looking good. All right. So I don't really think I even need to have that open probably.
And I'll start posting that around. I'll just start seeing search for different free energy type stuff around X and just start posting on people's posts and comments and stuff.
Oh, there you go. Cool. Yeah, and then I'll get let's give it like another 2 minutes or so, and then I'll get us started here.
Okay.
But I'm gonna share the YouTube stream to the Sign Team Telegram.
Cool.
Also, I have we could talk about later, but we can also stream on Telegram. It would be worth it because I have really good reach there, and a couple of my friends stream there already, and it works out. It just as like an outlet to have as extra.
Wonder, I mean, that's not going to be integrated into StreamYard or anything. We'd have to add like a separate thing.
Yeah, I'll just click it on there and share the one screen or whatever.
Oh, okay. Yeah, gotcha.
Yeah. Even if they don't get the whole deal, I'll put a link in there to send them to the full stream, and it'll be good.
Cool.
Kind of like the Spaces thing. Yeah, you know what? When we get to the point where we have a Spaces going on and stuff too, we'll also have the Telegram in there.
Cool. Yeah, that sounds good.
All right, I'm just trying to get this. Okay, there's our live stream. Let me see that on YouTube. I haven't looked at that yet. Okay, mute. Okay, it looks good. Take that link. Okay, yeah, I'm not sharing my screen, just the tab. So actually, I can open this up. All right, so I have Austin said he would be down to react to episodes, the first 10 episodes.
Cool.
So we'll start getting him in here on some of them. And then Steve sent me the one about 5 that he likes. I asked him to send me like 5 more. So I at least have maybe roughly 20 that we'll have at least one more person if sometimes you can't show up for any reason. But I know we have the schedule now, so it should be good. But we should at least have 1 or 2 more people on some episodes. So
awesome.
Yeah. And then let me share this here. Okay, so when I paste the YouTube link into Telegram, it has all the correct thumbnail and metadata in it. So it must be X doing something weird.
Good to know.
Yeah. Okay.
I'm posting it in the comments on a 9/11 revisited page. It's one of the top posts on.
Oh, there you go. Yeah. Get some understanding of some energy weapons. Yeah, and I figure over time things will get better. Like once I get into the shop type space, I'll have a little set, you know, it'll be a little cleaner, and I'll probably have like some stuff in the back that's themed and everything on my camera.
Yeah. Oh yeah, I'm sure we'll progress over time. Oh, why am I totally spacing on his name? The Martin Fleshman Memorial Project.
Oh yeah.
Who's the guy who runs that again? I'm totally spacing on his name.
I don't remember.
Yeah, I know neither of his, because his handle's Quantum Heat. I'm totally
Yeah.
spacing on his name. He's great. He's at Cosmic Summit, and I've been in a couple spaces with him, and he's fantastic. I just posted on one of his posts too.
I think Quantum Heat might be a reference to Energy from the Vacuum. Has a couple episodes about that.
All right.
I think it's part 19. Okay, so yeah, it looks like we have one viewer. I always have one viewer on Twitch, and I honestly never know who it is, but there's always one viewer.
Do you think that's just standard mods, like, or whatever bots, like the actual?
Could be, yeah, could be like a bot or something, because it's always there. Okay, yeah, I think I'm ready to start. How are you doing?
Yeah, I just posted around half a dozen different places on X, so yeah, we can roll.
Okay, cool. So let's get this music off. All right. What's up, guys? Welcome back to the Energy from the Vacuum React series. Today we're going to be continuing part 1, overview. I did stream the first half of this episode where Tom Bearden covered some of the basics of how to extract energy from the vacuum in a general sense. And on the second half of the episode, he's going to be describing his Motionless Energy Generator, also known as the MEG. And this is a device that Tom Bearden created, taking advantage of magnetic fields to interact with the vacuum and produce energy. So today we're going to continue this episode. In the future, we'll try to finish the episodes in one kind of go. It's just this one happened to be cut up. So we're going to go ahead and get it started. Trying to think if there's anything else to say about it. I do have Aaron joining me today, Aaron Kessler. He is a new member to the Sign team. Say what's up, Aaron. Maybe do a little introduction if you'd like.
What up? Yep, I'm happy to be a part of this. I mean, just the whole dynamic and the conversations. This will be my first go through all the material. I know Rob has been through all of it already more than once, so it'll be fun to go through this while we're also connected with people on social media and online. This is definitely information that we want to collab with other people, get this out there, first-time listeners, but also people who have been looking at these subjects for a long time. So we can actually do real things in the world and take things from just theory to actual practical application as time goes on. So please definitely remember to like, subscribe, comment, and feel free to engage.
Amen. No, yeah, that's awesome, man. Cool. Yeah, it's great to have you here. I will say I haven't seen all of them. I've probably seen I don't know, probably half. And I've seen quite a few of them multiple times. I do know about the whole collection because I went and I spent a lot of time in a deep dive going and trying to collect all of the Tom Bearden information that's out there on the internet, whether it was the Energy from the Vacuum series or his multitude of books that he's written or his slideshows and PowerPoint presentations he used to do in the Army as a lieutenant colonel. So I went and, dug up a lot of that stuff. So I am very familiar with the series in general, but I've only probably seen about half of them. So yeah, without further ado, let's go ahead and just get this one started, and let's let Tom Bearden take it away. We'll try not to pause too much. There's a lot to cover, but when we feel the need, we will. And if we take too long, we might do like a quick few minute wrap up or something before we get going. Feel free to please leave some comments in the chat. I would love to talk to you guys. And yeah, let's go ahead and get started.
Let's go.
On 26 March 2002, the U.S. Patent Office issued a patent to Tom Bearden and his 4 colleagues, Stephen Patrick, James Hayes, Ken Moore, and Lee Kenny, all from Huntsville, Alabama, for their motionless electromagnetic generator known as the MEG. Legit. The MEG, which looks like a transformer, puts out more electrical power than is input. The MEG and its performance have been independently replicated by other researchers. That is, in fact, true. Hello? Sorry, the guys, let me close down something here. Okay, that is, in fact, true. And I went and sourced some of those replications. And when we edit this down into the YouTube video, all of these React series will be edited down into a YouTube video. And at that point, I will go ahead and include any documentation, links, or we'll put up on the screen anything that's relevant while we watch this. But there is someone that goes by Jay Lawden, I believe, and he did an amazingly in-depth replication of the MEG, and it's all documented on his website. So I'll be sure to put that in the description below. And also for further videos, that'll just be kind of the standard there.
With a MEG, we haven't gone to that stage yet. We're still in the open loop system where we haven't put the feedback. But it's possible to do that. We just are working things out one thing at a time. Here's what we have in the MEG. And here's why we can do it with the MEG, legitimately as proven in physics. In the MEG, suppose I have a toroid coil. A toroid is wound around like this in a circle, but it's wound all the way around it very tightly, and it closes back almost on itself. What happens in a toroidal coil is the magnetic field, the B field, is confined inside the coil. It can't escape outside. Normally, the magnetic field spills out all into space. We need to know 2 things. Magnetic field, any force field, is not a primary field of nature. The primary thing is...
Guys, one more reminder on the first episode and every episode going forward, don't forget to get a pen. You're going to need a pen. You're going to want some paper. Scribble down some notes, anything that sounds interesting. It doesn't even matter if you understand it. Just start drawing stuff, writing stuff down. I promise you it's going to help later.
Always a potential. And it's called a magnetic vector potential A. That's the name of it. Magnetic vector potential. Now, a magnetic vector potential is a weird beast. It's got 2 components, basically. One is swirling. It's a curled component. We would write that del cross A, and that is what we call the magnetic field B. And normally it hides the other component. It covers it to where we don't see the other component. The other component is one that doesn't have a curl. Doesn't have a curl. It's moving straight. So the curl of it is 0. But it's still a real potential. If you take this toroidal coil, first of all, we had to pay to get that B field trapped. But it's been found by Aronoff and Baum in 1959 that if I normally have a source of B field, and I just draw a dot here that makes B field, it's actually a dipole, and here's the B field spreading out in space, I know that's a curled magnetic vector potential A that I'm looking at, and it's hiding this other component I can't see. It turns out if you'll take all that B field, all that curl component, and pull it back in and hold it in a little area, localized area, so that it doesn't spill out into space, you reveal outside there that hidden component, the uncurled or the curl-free A potential. So isn't this interesting? If you localize the B field into a little small location instead of spreading through all space, you have all the B field energy you would have had through all space. You got that in your hand in this local space, but outside that, you've got a whole bunch of extra energy now in uncurled A potential form. Well, A potential is wonderful. In the curl form, it makes magnetic field. So if I've got magnetic field, I got all my curl component down here in this localization zone. And outside here, I have a new component of energy I didn't have to use before in my immediate environment available.
Okay, we're going to stop there, chat. So what he's saying is that if you had a magnet, the magnet has a magnetic field that goes out into space to infinity, and it falls off by the inverse square law. But if you were to confine that magnetic field into a limited space, you end up seeing something that you didn't see before because of all the noise of that B field that was radiating. If you shrink that down, now you see these straight lines going out. They're not curled like how the magnetic field lines are, how they curl out from negative to positive. They're shooting straight out of the poles to infinity. And you can't normally observe or work with that, which is called the A potential, unless you confine the B field. So this is a source of energy that exists in all magnets that we're not taking advantage of. And in the MEG, that is the first step, is taking advantage of this unused magnetic potential, which is the uncurled potential. And so that's what he's describing there. So we're not getting energy from nowhere. We've just learned a secondary place to get energy from a magnet.
Component of energy down here in this localization zone. And outside here, I have a new component of energy I didn't have to use before in my immediate environment, available. Isn't that interesting? Because it's easy to collect it. All you have to do is change it real fast. The time rate of change, dA dt, produces an E field in the opposite direction from where the A field was going, which direction it was heading. It makes an E field. And the magnitude of this E field that it makes, this electric field, is proportional to how fast you change the thing, the time rate of change. So, now wouldn't it be interesting if I could find a transformer core material and construction which would do localization of the B field? What would I have if I did that? Instead of just looking at the B field in my transformer, I would have the B field now inside the core material. But outside the core material, I would have a new available reservoir of extra energy in my environment. And all I got to do is perturb it, and it'll make electric fields, which come back into the system and introduce real electric field energy into the system.
Okay, so what he's saying is once you confine that B field and you end up with all of these straight lines coming out, how do you get electricity out of this new magnetic potential? You pluck it like a string. You perturb the A field and it gives you back negative energy. And the rate of perturbation, so time over amplification, I believe, determines how much energy you get back, dA over dt. I think that's what that is, yeah.
Which normally no transformer does. That's what we do with the MIG. We found, with this nanocrystalline material they're making for new transformers and all, we found a construction core right off the shelf, type of construction and nanocrystalline material, there's 2 or 3 types that'll do it, that if I make a transformer core material here, I'll draw a simple one. This is just a diagram. It's not exactly the way we structure it. Any source of magnetic field, for example, if I have an input coil here, like this, and I'm paying for the input, all the magnetic field from this coil, all of it, is trapped in this core. It doesn't get out, and there's no spillage out there into space. Interesting. How can I prove that? I put a permanent magnet very tightly across here. North pole here, south pole here. Got to have real good contact, no air gaps of this magnet. It's a very powerful little magnet. It's right across the transformer core material. And then I take an instrument with a field probe to measure magnetic field B, and I put it right on, let's say, that north pole. My instrument measures no magnetic field, or almost zero. It's impossible to get total contact. You will have the tiny, tiny air gap, so you will measure a tiny, tiny field, but essentially a zero magnetic field right on the surface of the magnet. Now that proves that all the magnetic field that normally spilled out of this magnet everywhere is got sucked into this core and is sitting there. When you localize the B field and expose around it that usually hidden, uncurled A potential, that's called the Aronoff-Bohm effect. Aronoff was a student of Bohm. Aronoff. Bohm was David Bohm, of course, as everybody's aware. And in 1959, they published a very formidable and fundamental paper in a physical review series pointing out.
Okay, so what he's describing here is how the motionless energy generator is going to confine the B field by itself. So normally, if you have a magnet and you have the B field spilling out into space, you could wrap a coil around it and then send a charge through that coil in order to interact with that magnetic field. But now you're paying for that. You just had to pay for that. But what he's saying is, suppose the core itself was made with materials in a certain way where they confine the B field just by existing in a certain geometry. And so that's what he's trying to explain here. And what that means is you get the magnetic field confinement for free. So now the first interaction that you do is you're just paying for the switch to pluck the string, to perturb that A field. And the way you're getting electricity through this interaction is it's interacting with the vacuum or the ether.
Hidden, uncurled A potential, that's called the Aronoff-Bohm effect. Aronoff was a student of Bohm. Aronoff. Bohm was David Bohm, of course, as everybody's aware. And in 1959, they published a very formidable and fundamental paper in a physical review series pointing out this effect. When you localize this magnetic field in the space outside this core, not in the core, outside the core, there appears this A potential. But it's the uncurled variety now. It's extra. I didn't pay for it. If you want to put it in proper gauge language, the Aronoff-Bohm effect gauge transforms the space outside the localization area, which means you see additional energy available there in space itself. That's rigorously proven in literature. Don't have to reprove it. 20,000 papers in literature. But it's not in electrical engineering, but it's in physics. The difference here in the MEG is we don't have to pay for what this material is doing. We didn't have to pay to get that extra A potential energy reservoir formed outside the core. That happened free. It's from that regauged space-time, which is a change in that vacuum. It's a result of the fact that this core material will do for free what I got to pay a toroid to do. Only it's free. I don't have to pay for that effect. If I got a toroid, I can get the effect, but I pay for it. I lose everything I'm going to get. I don't have to pay for it in this case. The material does that extra action for me. That's the beauty. Material effects, by the way, are one of those places already recognized in thermodynamics itself as violating the second law of thermodynamics. Material effects, like long-term memory and all kinds of things. Read Prigogine and Condiputi's book, Modern Thermodynamics.
So by violate thermodynamics, what he means is the second law of thermodynamics, is relative to a closed system. But the MEG is dealing with an open system. When you're interacting with the vacuum, you actually have an open system. A closed system could also be referred to as an equilibrium system. An open system is a non-equilibrium system. And so it only violates the second law in the relative sense. Once you account for the ether, which is proven by the Casimir effect and the Aronoff-Bohm effect and a whole bunch of other things, once you account for that, now you understand you're going from a closed system to an open system, and that's how you're able to violate the law of thermodynamics as we know it. It's only relativistically that we're doing that, but really what we're doing is we've just found a workaround. So what do you think so far, Aaron?
Oh yeah, I'm with it. I'm also doing some of the stuff on social media, so I'm half in. But it's interesting. It's talking about putting it into the actual coil, so it's actually putting the field into the iron core around it, right? Instead of an actual projected toroid. Yeah. So yeah, I'm excited to get this the whole picture. I think things are going to start coming together as he's starting to do some actual application.
Yeah, definitely.
That deals with all kinds of in thermodynamics itself as violating the second law of thermodynamics. Material effects like long-term memory and all kinds of things. Read Prigogine and Condiputi's book, Modern Thermodynamics, that deals with non-equilibrium systems. You will find that that's one of the areas that is known by the thermodynamicists themselves to violate that second law. So I don't have to prove it.
So I will say also on the Sign Academy website, we will eventually have a physics library, which will have readable copies of many of these physics books, articles, papers, and everything that we can get our hands on, patents and everything like that. We're going to go ahead and host that information for free all in one place on the Sign Academy website. That's not available yet, but we are doing our due diligence to make sure this information can be referenced and it can be, just easily learned. And I've already done some of that digging and even found some of the more potent like figures and articles that really are kind of the home run material. But we're going to have additional stuff like that too on the Sign Academy library eventually. So we'll keep you guys updated on that as well.
Violating it permissibly. It's already been done by a Nobel Prize winner. So what we have now is, I have an interesting situation. I have what looks like a normal transformer core, but there's a very abnormal thing happening in it. All of the magnetic field B is now confined to the core. And around that, I've got all the magnetic field energy, the swirling energy that I normally have in every transformer. I've got all of that. I haven't lost anything. But in addition, I've got this extra energy reservoir in space just outside the core. And every time I perturb the core, like with my input coil, I put in, clever devil that we are, we put in pulses, sharp rise time and sharp decay time. If I want to get a little bigger E field, I make a sharper rise time and a sharper decay time. I get an E field one direction one time and the other. And what happens is the space here, I can have as many coils wound on this core as I wish. Let's put an output coil on it, just to say we got an output. And it looks like I got my drawing a little bit reversed, but that's okay. There's an output. And over here, I got a big load. But in this space outside the core, I'm going to shade the core here so we can begin to see what this looks like. In this space outside where my uncurled A potential is, and I'm going to put a bar over that A to mean that it's a straight moving A. It's not a swirling A. It's not a magnetic field at all. Every time I shake or perturb this A potential, it makes an E field. E equals minus dA dt. And the sharper the change, the greater the size of the E field. From space around the core, this does not happen in any other normal transformer in the whole world, as far as we're aware. From the space outside the MIG, there arises then these tremendously strong E fields, which radiate into every coil that's wound on this transformer. So every coil on this transformer that's wound, I could have a dozen.
All right, let's take a look at that real quick. So right here in the middle is that square core that he drew on the paper.
Okay.
And then on the sides here are the coils, the input and the output coils. And that's about as much as I know from there.
I was going to say, and then is there a permanent magnet in the center of that then?
Yeah, it is. Right? So there's inside of this core, there's two materials. There's a permanent magnet in the center, and then that's sheathed in another material, which automatically confines the B field. And so that's what we're seeing there in the middle.
And what he was talking about too, I mean, because Jason Verbelli talks about this too with the Searle effect generator. So it's not actually creating energy; it's taking ambient energy and compressing it. And it'd be interesting because on that design too, I mean, it's got different cores. They're in a circle, right? These are done in these kind of squares, the way they're setting it up. But it's got concentric circles with a cylindrical neodymium magnets that rotate around, right? But it's compressing the electrons the way he describes that. So you're actually enhancing it sounds like it from the vacuum, the amount of energy you can get from the ambient environment.
Yeah, exactly. And the beauty with Tom Bearden's Meg is there's no motion. It just sits there completely still. And by simply perturbing that core, you get the energy out just because of the makeup of the materials and the geometry. And hey, what's up to everybody in the chat? You guys are officially our first chatters.
First ones. Let's go. That's sheer, baby.
Coils on here.
Let's go.
Every one of them is also, regardless of what other function it's producing, is also an input coil for energy coming in from the vacuum in electric field form, not magnetic field form. The biggest action in the MIG is an electric field transformer, not a magnetic field transformer. And we're using a proven effect, Aronoff-Bohm effect, that 20,000 papers in the literature already tell you happens for real. We didn't dream this one up. We just found how to do it for free. How to get it to happen with the material doing it for us instead of us have to pay a toroid to do it and lose all the advantage. Every coil then has got E-field inputs. That's in phase. The funny thing about our output, a normal transformer output will be up towards 90 degrees. It's 85 degrees. It's got some resistance in it, but it'll be like almost pure reactive power coming out of it. That's not true of the MIG. It'll be 2 degrees. It'll be essentially in phase. It's almost pure power, and not a real power, not reactive power. And it's in pulse form. And so what we have to do, we have to add another unit on here, standard technology, to change these pulse forms into a normal kind of power form, like oscillating current or DC current, whatever. So you just go buy that off the shelf from people who are experts and do it very efficiently. But what we really have that's significant, it's not a regular transformer. We have an extra energy input from the environment that we don't pay for. That's the key. Now let's draw the MEG diagram, and it turns out to be just like that crazy heat pump. I have my system called the MEG. I'm going to do the open loop. I'm putting in the operator input. I'm paying for that.
Oh, you're muted.
So he just mentioned something. He said it's going to be just like that crazy heat pump. And what he's referring to is in the first half of the video that we streamed previously. He showed how a heat pump is a device which is common on the planet, and they all produce a coefficient of performance over 1. What that means is you get out more work than what you put in. Now, that doesn't mean it's 100% efficient. But the reason that that's possible is because a heat pump or an air conditioner is using the ambient temperature of the environment outside or inside in the system, and then compressing by absorbing or releasing heat or cold. It's compressing gas. And so you're getting a net gain. So he had shown before in really simple terms how almost all standard heat pumps are already a coefficient of performance over 1. That's what people mean by free energy. You put in 1 volt, you get out 1.2. That's a similar thing, but a heat pump is working in heat energy. Heat energy is highly inefficient, very hard to work with. You don't really want to work with it. It's hard to transfer into other types of energy. But it just goes to show that you can have more work out than in. And so now what he's going to show is how this works relativistically with an electromagnetic system rather than just a standard heat pump. But it's the same exact model here, how it works. We're using a different medium that's available in the environment. He's using the magnetic flux that comes from the B field in his core. Okay.
Paying the power company, or paying for a battery or something. But now from the environment, I have this extra input of energy, and I'm going to put the bar over the A. And when I perturb it, it's going to be in dA dt equal minus E. Instead of going out, it's going to come in. So now I have an extra input of energy into my system free from the environment, just for putting in the input I'm putting in. The other part comes along for free. I get that as an extra added attraction. So if I put in 1 part and I get my input from the uncurled A potential active environment, the E field input, if I get that to be, let's say, 5 parts, be very conservative here. I can make it 10 to 12 or 100 parts, but it'll burn the insulation right off the wire then. It'll destroy the unit. But suppose I settle for 5, I adjust the rise time and decay time until I get this 5 parts in. Now, coming out, I have input here 6 parts total. The part I put in, I pay for. The 5 parts that the environment puts in, I don't have to pay for. So I have 6 parts of energy coming in here. A normal transformer can be about 85%, 90% efficient. Recapitulating, I pay to input 1 part. The environment is now, by the way we have it adjusted, we make the adjustments in the input until we get this effect, let's say, it's putting in 5 parts. And now we have a total of 6 parts, total energy being put in here. Okay, let's suppose this is 90% efficient. Coming out of that, then, I'll have 90% of the 6 parts, which is 5.4. So my energy that I'm getting out is 5.4 parts. Okay, what's the COP? I put in 1, I get out 5.4. Divide 5.4 by 1, the COP is equal to 5.4. I get 5.4 times as much usable energy out as I get in. This is just an energy converter. Now, when I add another stage on here to convert that into a standard kind of power form, either direct current and certain voltage or so forth AC, I will have an inefficiency existed there. Maybe I'll cut this down. Let's do real bad. Let's cut this down to 3. Let's lose 2 points, almost half of it. We didn't have too efficient a conversion, let's say. We were sloppy. We didn't go get the state of the art. We're much better than that. But even with the bad one, once we have it set to run loads, and actually running loads and lights and motors, we're putting in 1 part, we're getting out 3 parts. We have a 3 to 1, we have a 3.0 COP practical. And that's 3.0. This is a standard achievable thing with a MEG. Okay, then the question is asked, then why don't you guys have this thing on the market in mass production, rolling everywhere? It's a very good question, because let's see why we don't have. What is going on in the MEG that we went through? We pointed out that the E field hits every one of those coils. There's a little bit of out of phasing and everything. They're not all on the same phase. And each coil, once it gets an E field, fires at every other coil, and everything's feed forward, feedback. That's a highly nonlinear situation. And that is the devil and all to try to precisely measure. Trying to measure an individual signal in a dense signal environment is not a simple thing. There are people can do it, but it requires special instrumentation and highly specialized measurement equipment. Forget your normal oscilloscopes and probes. You can never straighten all of that out. You do it by trial and error and adjust it.
Okay, so what he's beginning to describe is one of the first challenges in manufacturing the Meg at the time that he created it, which was 2 decades ago at least. And I think he started building them maybe 15 years or so. But what he's saying was, even though you can measure that there's this new energy potential from doing this, it's hard to tune it. So when you have, let's say you've got one input coil and one output coil, well, that's fine. But when you start adding on more coils and more inputs in order to increase that output, you're getting a lot of noise from all of the input coils. Additionally, you can't tell which input coil is hitting which part of the A field because there's too much noise. And so at the time that he was trying to measure the results of this and actually tune it and get it optimized, he had an issue with the instrumentation. He had an issue with people having the expertise. And in addition to that, I don't know if he's going to get into it here soon, but there was also a materials issue. And even for the longest while, once Tom Bearden passed on, people who were trying to replicate the Meg, they didn't know exactly which core material to use, but thankfully it is out there on the internet. I'm not sure at what point it got released on the internet, but people were able to find it. And some of the people who replicated it were able to find it. And they were also, more importantly, not just what is the material that they're using in the Meg, but where did they get it? Because I've heard Tom Bearden mention that he found mainstream companies to manufacture the core for him. Well, it turns out, I think Honeywell was one of the companies. And I actually have a list somewhere that I'll make available when we edit this down. And it's a list of the 3 different manufacturing companies and the part numbers at the time that Tom Bearden was doing this, the parts that they made. So it actually is possible to get these cores made again, so I think that's pretty cool. But let's go ahead and see more about what he has to say. And then let me back it up a little bit. How are you doing, Aaron?
Yeah, doing good. Lots of thoughts and ideas, but nothing that's coherent yet. So definitely keep taking it in and spit something out when I get it.
Cool.
Precisely measure. Trying to measure an individual signal in a dense signal environment is not a simple thing. There are people can do it, but it requires special instrumentation and highly specialized measurement equipment. Forget your normal oscilloscopes and probes. You can never straighten all of that out. You do it by trial and error and adjust it until it's mostly additive. What we need now is to do all the precision modeling and all the precision work, to work all that out with a math model, to work out the actual measurements and the characteristics of the material, how that affects it and all this. That's 1 year of very hard work. You've got to have 4 specialists in special areas to work with you.
Okay, so the way they got around that to make sure there were improvements if they did do something different and what they thought would make improvements is they just kept tinkering with it. Stick a probe in it, move it. Stick a probe in it, move it. Read the tools you have, and they just had to figure it out, right? Once you have that, now you need precise modeling. Now you need to give that information to people who can model this and design an optimal system, not just us stinking around in the shop with our tools and this couple of things we bought from Honeywell or whatever. It needs to be taken into a full design phase and digested down. And that was another problem at the time that he was having with getting this made.
To do it. We're trying to measure all those exact signals and work out what we would call the transfer function, exact mathematical model for the transfer function of the Meg. If you build those all out of phase so they're subtractive rather than additive, you'll build a worse transformer than a normal. You'll be better off throwing all that away, build a regular transformer. But if you get them additive, you beat the heck out of every other transformer in the world because it goes way over unity. We don't have good control and good models of all of this. What we have to do is adjust everything by hand, and that's not science. We have to keep tweaking the heck out of it. And so what we have to do is a standard, but very interesting and very dense, highly nonlinear control problem, an adjustment problem. We have to have modeling, full modeling for it. We have to have an Aronoff measurement specialist, Aronoff bomb measurement specialist. Those guys are well employed. There's very few of them that know a measurement also. You can get them, but they're expensive. We have to have another person that knows nonlinear oscillation theory, and also we have to have another one that knows nonlinear oscillation.
Hang on, chat. I just have to laugh because you just said you need an Aronoff Bohm effect specialist. Meanwhile, a lot of the people watching this video spend half their time on Twitter arguing as to whether or not that's a real thing. There are specialists to measure it.
Marius also said we found a company, or haven't found any company, or we've found a company that specializes in wiring motors and transformers. Will happily make a device on set design, on S set design.
Okay, on a set design. Oh yeah, it sounds like he's saying they could build one. We have found a company that specializes in wiring motors and transformers. Will happily make the device on set design. Yeah, I think that's what we say. Right on. That's interesting. So another thing that Sign is doing, and we'll make some other streams and videos more kind of in the nuts and bolts about Sign, but another one of the things we want to do is replicate a lot of these old school free energy machines and devices and stuff. There's a whole lot of them, you know, like the Cromry converter, the Cromry converter. That's hard to say. Say that 5 times fast. That one's one that keeps coming up. I'm interested in magnetic motor generators, even though you can do solid state generation. I think it's a cool stepping stone. I think they're still cool, and I think we should clear the air on the ones that don't work and the ones that do. So Sign's going to go through and do that. But yeah, I'd be interested in reaching out to you, Marius, when we do get to the Meg, because I have it on my list. And I don't know if we're going to actually, you know, if we find out it's like a lot of money to go all the way, we might not do it. But what Sign is all about is proving the proof of concept. So we want to take all this stuff that people had done before, and we want to create a modern proof of concept with a white paper that other people can replicate, all the parts and tools and pieces in the video and everything. And that way we can start our own internal peer review process within the community. And we don't have to listen to all these like naysayers and armchair warriors about whether or not the Meg would work. It's like, yeah, well, we already proved it in the shop. So anyway, next.
Control theory. Those are specializations. You don't run down to your local university and your local PhD can do that. The interactions have got to be moved to design and science and modeling rather than fiddling with it. We have a $9 million one-year job with a team, including not only the normal guys, but those 4 specialists we got to hire that are very highly paid, by the way, I might say. And they're fully employed gainfully. They're not looking for a job.
By the way, what voltages are you working with? What level input and what level output? 5 volts, 10 volts?
Well, normally we try to put something that'll power something. So we're going to reduce whatever we come out with the output voltage. We're going to reduce it to like 120 volts or something like that. Now we can produce 1,000 volts or 5,000 volts out of this thing and burn the insulation right off the coils. Normally as an input, we'll use a battery or we put in a circuit in front of it, which is a switching circuit to do the switching to make it oscillate and give us the rise time, get the decay time. So you put in a circuit to do all of that and you adjust and tweak the circuit for the various tunings you want to do. It's a sort of a tuning nightmare almost to get everything properly tuned. But when you properly tune it, it does produce what I've got on this paper. But you can see right away, this is not a simple problem. I don't go get me some transformer guys and whomp up some of these and go sell them. Now, you got your choice about how you fund this. The normal scientific community is not going to fund it. They say you can't do that. Electrical engineering says you can't do, forget it. So what you're going to have to do, you're going to have to go to venture capitalists. Here, it's a mixed bag, a mixed breed. There are some good venture capitalists. There's a whole bunch that ain't too good. You cannot work with, as we discussed before, with a government agency. They'll steal you blind and patent around you, all around what you've done. So you're still going to have to go to a risk venture capitalist. You're going to have to convince him that the risk, in fact, justify the investment on the front end. If you look at the risk analysis figures, they're great. How big a payoff is self-powering systems and systems that produce a steady 3-to-1 output electrically? They say once we run it through the hopper, the year that we want to do on it, where we have good models that we can design it in advance, we can put the coils exactly like we need them, exactly where we need them, exactly with what orientation and so forth. Once we can do all of that from the front end, we can build the thing straightforward and put it together and it'll work just like that. You've made it a technology and a science at that time, not a twiddle with it research outfit. We have a lab bench experiment that's successful. We do not have a ready for production device that can be cranked all across, by the thousands, put on the market. We're approaching all the control problems first. We have to do all of that first. Now, in the United States, we tend to be stupid a lot of times. We took nonlinear oscillation theory and control of nonlinear oscillation and made them 2 separate fields. If you use the U.S. control system, the guy will have you chasing strange attractors for the next 10 years. If you go to the Russians, they'll laugh like the devil at all of that, and they'll say, there's no problem, even random oscillations we can control straight away with our theory, but they put the 2 together as one field. Fortunately, their results of their control theory, which is far superior to ours, are now available in books in the West. We have a few people now who understand and are trained in the Russian system. So we would jump all that other stuff and go direct to the Russian control system and use that to begin with. Once we have the math models, we have the phenomenology fitted to it, and we have the ability to design.
Convenient how there's a geopolitical tension with Russia all the time, isn't there?
Yep.
And build and scale up, and it'll work that way with just minor tweaking. At that point, we're ready for production and marketing. We're not right now. We are ready for the final stage of development to go from a lab bench experiment, working successful, to pre-production model ready to go into production engineering and production. The beautiful thing that we have a recognized, proven, certified mechanism which does re-gauge that space around where the air-enough bomb is effect, and it's in the literature and proven. I don't have to reprove it. So is it scientifically proven? Yes, in the literature. Will the scientific community accept it? No. Because what they do is they say, oh no, it's a power problem, it's electrical engineering. Electrical engineering says you can't do that. Now, they have been using the air-enough bomb effect since 1959, but they've been paying for it like in little toroidal coils, not getting it free. And the other thing is, the people who have been using it are people that do itty-bitty quantum mechanical experiments. Nobody has thought to use it in power.
Mary said, I was just about to add, the biggest problem was tuning it. We found the number of windings and placement kept changing. For us, it was hard to replicate because of not having the same frequency.
Interesting.
In the core. So adjustments had to be made. Yeah, I was going to say, I was trying to visualize how this would be done. I mean, it sounds like they're tapping into different points on the input core, right? Different phases, basically, of trying to hit the constructive wave interference with the phase of the input coil in a harmonic way instead of being destructive and losing efficiency.
Yeah.
But how would you do that? That sounds tricky. And apparently it is.
Yeah, and you want, once you can tune the system, you want as many tiny coils as possible. You don't want a few bigger coils, you know. So the more coils you start to add to the system, the harder it gets to tune. It's like adding more strings to a guitar, you know, and trying to make chords that work and using all the strings, you know.
Yeah, keep the river flowing. Yeah.
Yep, true that. And he was saying something there. Let me back up real quick. I think I had a couple thoughts.
And using it are people that do itty-bitty quantum mechanical experiments.
Yeah, what it is that he was describing how in Russia, they kept certain subjects in the universities together, like self-oscillation theory and some other stuff that he was saying, and, you know, particle physics and electrical engineering. They teach the relationships with those. And in America, they don't do that. If you become a physicist or a particle physicist, you're not going to learn anything about electrical engineering. And if you take electrical engineering, you're not going to learn anything about particle physics. So trying to teach a physicist or an electrical engineer to agree is, like, you know, very difficult. And so we've been going like that for multiple decades.
Yeah, and that is the pros and cons of decentralization or compartmentalization. I mean, in some ways it can be beneficial, but otherwise you can't make any progress. You have to have interdisciplinary overlap or you're fucked. Ultimately.
Yeah. And that's one thing that I'm interested in, is trying to find all of the fields in the US that have been divided and try to cross them back together and provide information and show people those relationships so we can start to undo that thinking. Because, you know, not only is it clear that there are relationships, but it's experimentally proven. It doesn't have to be clear to your eyes. You know, if you're someone who wants to see the information, this is all old information. I mean, this video was made in 2007. Most of the articles and things he was referencing are from the 40s and the 50s. So, I mean, we're talking about a long time here. People have known this, and it's just a matter of, you know, what do you require as an individual in order to finally believe it, I guess.
Well, and this is all public-facing information, right? Now, I mean, not to mention the countless papers and things that are in the secrecy acts and, you know, that we don't have access to. So we're trying to piece things back together in the public sphere that they probably have known about for a very long time. And they're, you know, keeping one eye looking over what's going on in the public sphere, because eventually we're going to figure it all out. It's inevitable.
Yep. Yeah, 100%.
Nobody has thought to use it in power.
So your general operational control is the square wave or the cycle density.
It's not exactly a square wave. It's a sharp rise time, sharp decay time. That's adjustable. The pulse width and the pulse repetition rate are all adjustable. There are many adjustments you can make. Everything affects this.
Really quickly, I just want to comment on what they said there. So when we think of a sine wave, what you're looking at is a curved progression, right? And then you can have a square wave, which is up, over, down, over, up, over, down, over, right? That's a square wave. Now, what he's talking about is a sawtooth wave, kind of, I think, which is where there's a steep incline, and then it's flat, and then there's a steep decline the other way. And that's important, because when we think about frequency, I feel like, at least on my own path and when I talk to people, a lot of times we think about all energy as a sine wave, but energy doesn't have to be structured in a sine wave progression. It can be structured in square waves, sawtooth waves, and stuff like that. And it actually, depending on how you structure it, just depending on the structure of the wave, never mind the frequency, it will do different things, you know. So there's a lot of pieces.
thing that you adjust.
What I'm asking about is your only danger is melting the insulation.
No, there's the real problem is not that. We can solve that just with the rise time, decay time. And we've got that problem solved. But the problems that are difficult, really difficult, is where you have all these high nonlinearities and feed forwards and feedbacks. You actually have a very dense signal environment right inside this thing. You have to measure individual signals in a dense signal environment. That's a tough job.
But in theory, you could build a system where all of this is automatically calibrated.
Once you have done the technology and the modeling, yes, you can do that. Now, if we
Chat. What if you had some kind of a sensor, I don't know what kind, on every coil, and that was hooked up to a Raspberry Pi? So you could have a live information export of all the coils. You know? Because I think people use Raspberry Pis to run like mining farms and stuff and look at all their GPUs at once, the temperatures, the fan RPM, the, efficiency.
Yeah, I think it's just a base framework. I mean, there's a lot of programmability and versatility, I think, with those. Yeah, and if you had some kind of monitoring each coil, it makes sense. It's a good start.
He said you can't use an oscilloscope. So what if you measured the back EMF from the coils away from the core where there's no interference and used those as breadcrumbs? I could be totally wrong. I don't know anything about electrical engineering, but I just had that image in my head.
want to close loop this system, let's take this same system. Let's put it real efficient. So efficient, I'm going to say it's 1.0, because we can get 0.9 if we pay for real good guys to do it. But for ease of calculation, let's put a feedback system on this thing. And let's say it's 1.0 is 100% efficient. So I don't have to worry about that figure, because this 5.4 might be bigger, see. I'm using my 3 here with what we really got of it in practical after we got the shaping for loads. I'm paying that price. The actual output is 5.4, but I'm only charging the 3 because I'm willing to pay. I know I've got to pay that conversion price. It's not going to be that much, but I'm going to be very conservative here. So I'm going to pay 2.4 points and leave my 3. Okay, with this 100% or nearly 100%, I'm going to feed one part back. I'm going to leave 2.0 as the output. But the one part that I feed back now can remove my generator. And it's furnishing, for part of its output, is furnishing that input. This is clamped and governed, so it's not going to run away. Okay, I'm now reduced to 2.0 from what I had been doing that was all the way up to 5.4. But that's free energy. It's coming out, it's coming right out of the environment, and it's continuing, and I'm not paying anything for it. It now is the equivalent of a solar-powered system, or a hydroelectric-powered system, or a windmill-powered system. And its COP now is infinity with a...
What was that?
Oh, it just glitched out on me. Froze up for a second. Was it good on your end? Or was it clean?
Yeah, I think we're okay.
All right, yeah, go for it.
So I just want to look at this a little bit. It's getting a little complicated here, but what he's essentially describing right now is on the left side here. Is my mouse streaming? Yeah, it does. Okay. Mm-hmm. On the left side here, you have the original battery and the switching circuit. And that gave us our one part of energy. The one represents whatever the power level of that battery is.
Mm-hmm.
It's coming in here into the MEG. The MEG can produce 6 power. It's 90% efficient. So that means you're going to lose 10%. So the output is going to be 5.4, which is 0.6 less than 6, or 10% less than 6. So now he's saying he's sending the stuff out to the loads. So he's going to lose 2.4. And with the 3 that he has left, he's going to borrow 1 out of that 3. So he's still going to have 2 left. And he's going to send that 1 over here. It's going to cross this 90% efficiency again. So it's going to be 0.9. So he's going to need to send like 1.1. But just for the sake of easy math, he's going to take this 1. It's going to come over here. Once the 1 comes in front of the battery, now you can take the battery off. You always have 3 coming out, and you're only taking 1 away to come back to perturb the MEG again.
That makes sense. An actual recursive system. So it's just an efficient way to use your output. That makes sense.
Yeah.
Closed loop. Once I disconnect that generator, once I get it going and stable and operating under load, all the controls working, everything's stabilized out, I disconnect the generator. That's Krone's condition, by the way. Krone laid that down in 1945. The great Gabriel Krone, who built a successful negative resistor and self-powered the network analyzer at Stanford University, laid down the condition for making it self-powering. So we're just using Krone's method.
I found out a secret, guys. I'll share it with you a little bit. Look into Gabriel Krone and negative resistors. That's all I'm allowed to say, because I was asked not to say more. That's all I'm going to say.
I am not free to name the university that's working with us. We are working with a foreign university. We had to go completely out of the United States before we'd find one that, in addition to non-disclosure, would sign a non-circumvention agreement. An inventor can't work under just non-disclosure. He's also got to have non-circumvention. You must not say that I'm going to change some coils and all and patent this thing all around you and run off with it. So if you have a non-circumvention agreement, you can work with them. We could find no U.S. universities that would work with us under non-circumvention because they are charged with making patents, and they'll try to out-patent you on your own device.
Yep.
We found one in a nice foreign country, and we're very satisfied with those people, and we're working very close with them. They are deliberately, to be purely scientific, staying independent of us. They will not accept funding from us. They're using their own funding, which is meager, but they're using their own funding, so scientific independence is being maintained. The things that I've described we have to do before we get to ready for pre-production engineering is a minimum of 1 year and a minimum of $9 million. Any way we price it, when we get the people that we have to have, the specialists, the equipment, the new test equipment, the new methods of test, new test guys that do that kind of testing, it's an expensive proposition. It's not cheap. But that's peanuts compared to what we're spending on hot fusion or what we're spending on all kinds of things, fuel cells and things like that. They're spending billions of dollars here. This is scalable. This is doable. Now, there's one other way we could do it.
Whoop. We lost Rob. His computer might be resetting or something. So in the final edit, you won't see any of this. We'll edit when Rob comes back and we finish the continue on with the video. But for now, yeah, it is super interesting. That's also reminds me of what he was just saying with the amount of funding, because there's the ENG8 team over in Europe that has a I think they have a COP of 3 or 5 on a fusion plasma device, I think. And they needed several $1 million in funding just to get going on that too, which they were having a hard time getting. So it's, I mean, it's just the state of the world and the culture. Most of these technologies have been hidden by the Secrecy Acts.
Okay, sorry about that. Somehow my stream switched to a different camera that's not active, and it disabled all my audio. Am I good now?
Yeah, you're good. You're back on.
Oh, I don't hear you.
Oh, I can hear you.
But we could sell stock and raise stock from investors, and I could make all kinds of songs and dances, and so could the rest of our.
Live stream technical difficulties.
Oh, okay, I see me.
Can you hear me or no?
I don't hear you, Aaron. Can you guys hear me?
I can hear you. And let me see.
Okay.
Yeah, I can hear you. Yeah, go ahead.
All right, I'll keep going and then just try to chime in, Aaron. I don't know why I can't hear you now.
And we're both coming through on.
We prefer not to do that. We are seeking one single risk venture partner that we can work with. It's an honest group or people. We can work out a mutual arrangement for both our benefits, and then we can get on with the job. Now, what we refuse to do is turn control over to it. We could have gotten funding if we would surrender control and guarantee it never makes the market. We have no intention of doing that. So we will stumble along until we get funding that we can still guarantee it'll go to market, or we can give it the best shot that human beings can give in the world. We're not going to take something and park it on the shelf, and it's just one more system that never is going to make it.
Okay. So what had happened is I paused it before and it switched cameras, and now we lost Aaron's audio there. But what I was going to say back here a little bit, you know, he was talking about the $9 million and the 4 specialists and the 1 year minimum and all that to produce a couple of these or whatever. And he was comparing it to some other energy types and stuff like that. I will say now, being almost 20 years later, not that the Meg wouldn't be the best option, but it might be, you might get more out of $9 million. And if you think about $9 million in 2007, I mean, I'm not going to do the math, but it's probably like 12 now or something, maybe even more. So you probably need like 15 million. And just because I've sort of broken down a lot of these different machines and their viability, I think you could do a little more with that money outside of the Meg. Now, if we already understood how to make it so we could scale it down or up or whatever, but make it more efficient and more powerful, then it would probably be worth it. But putting that much money just to get it figured out, it's like by the time you go through that $15 million in that 1 or 2 years and you get everything set up, now you need another 10 million maybe to do a production run. By the time all that goes on, like, you know, there might be better things to do. So that's a tricky thing with some of these too, you know, is like, what do you do? It's like, right now we have a project going on where we're using Stanley Meyer's hydrogen concept, where you extract hydrogen out of water and have a quote unquote water powered car. We have a Honda Civic car that we're bringing to the drag strip, and we're going to try and put Stanley Meyer technology on there. But at the same time, is when it comes to, like, you know, power output from the engine, it's almost not really the most economical thing. You know, it's like I could just put a turbo on the car and it would actually be way faster and cheaper. But, you know, to me, it's about the science and it's about the technology. And sometimes you just find out, well, that technology may not be the best thing for cars anymore. You know, who knows? It's like, now that we have things like Teslas, if we could get like a healthier battery pack in there, let's say, and a healthier circuit in there, let's say, where you're not relying on the grid and you don't have these, like, you know, batteries that need to be made better and with less toxic materials and whatnot, then maybe you just do go with like electric cars. Now, here's the thing. I'm a hardcore, you know, old school mechanic. You know what I mean? So I'm always going to have like a gasoline. My car out front right now has a distributor on it. Do you know what that is? Do you know how to turn a distributor by hand to set the timing, the ignition timing on a 1997 Nissan Pathfinder? I don't know if you do. But I love doing that stuff. But I'm just saying where society is headed towards, where efficiency is headed towards, you know, who knows? And at the same time, why not produce super like era accurate old cars that have a really efficient battery and a gasoline engine that actually uses a healthy fuel? You know, why not do that also? But I just think where things might go is maybe it's no longer time for the Meg, or maybe it's no longer time for the water powered car. You know, who knows? I don't really know. I've seen water powered rockets. I mean, that seems where they're actually burning the water. It's not hydrogen conversion. I mean, that's nuts, you know? So, and I don't even really think rockets are the end all. So why use that for rockets, you know? So who even knows where all this is going to go anymore? It's nuts.
Some of the breakthroughs in the past have been deliberately suppressed. I will name a few. For example, Nikola Tesla had one. Basically, his big magnifying transformer that he had on Long Island was such an over-energy system. The way that one apparently works is he got the entire Earth itself in resonance. The crust of the Earth, as you go down in there, is made of highly nonlinear materials, particularly when you get down to the perovskite or whatever you call that stuff. And it will act in the bulk even. It will interact in a sort of a nonlinear optics fashion. It will do phase conjugation. And so eventually what it does is everything going on is feeding energy into the Earth starts to feed energy into that wave that he created. So he gets a lot more energy in his resonant wave fed from outside, from the environment in the interior of the Earth. And that's the way he built up a humongous wave of energy. His idea was you could then put in a tap on it anywhere else on the world and extract it free. And of course, J.P. Morgan's
Okay, now I want to clear up a misnomer. People think that the Wardenclyffe Tower generates that wave and then emanates it out through the atmosphere across the Earth and bounces it off all the layers around the Earth to the other Tesla towers. That's not what's happening. What's happening is the tower is in phase resonance with the Earth, and now it's a wire with the Earth, just like the Earth is the ground. And so you can now send electricity through the ground. In a battery, where do the electrons leave? They leave the ground. So if you create a whole bunch, all he's doing is creating a bunch of wires sticking out of the ground that are tuned to the Earth's frequency, so they can transmit that and pass that energy down that highway just as if it was the Earth itself. And then by pumping this wave into that, he's generating the positive wave and pumping it into that negative rod down into the Earth. If you create matching in-tune rods anywhere else in the Earth, now you emanate that E field and you can tap into it, create the transformers and have. So it's not going through the air, it's actually going through the Earth. So that's one thing that I find people confuse actually with the Tesla Wardenclyffe technology.
Take on that was, that's foolish. You can't put a meter on it. So that actually doomed much of Tesla's career at that point when Morgan found out that Tesla was going to produce the energy freely. Small cost here at a central location, everybody else could tap it for free. It wouldn't have powered the whole world today. It would have powered much of the world in those days. Tesla also, we're pretty sure, put a system in a car and ran a car on it. And the reason we're pretty sure is his nephew who rode in the car with him is still alive and can describe the incident and how the engine had no gas, no input of power, and would still run once Tesla got it started. And we know it's perfectly possible. Tesla apparently knew how to use this giant negative entropy process that's universal everywhere. Energy is free for the taking from the vacuum anywhere you want it. We just have to learn to use that. And before Tesla, there was an American engineer named Stubblefield. And Stubblefield found out how to take the energy out of the earth and take it out of what's the natural potential. But Stubblefield had found out how to manipulate that kind of thing from the background potentials that are there and limitless, that normally we just see a big zero, almost zero. We'll see, a tiny bit of, 1 volt or 2 volts or something. It can be turned into much stronger currents and power. And he found out how to do that. As a matter of fact, Tesla visited him. And there's at least one picture of Nikola Tesla in a group visiting Stubblefield. So Tesla was familiar with Stubblefield's work.
Stubblefield knew what he was doing, and he knew what radiant energy was. And he also probably had the first pulse motor. I did all those experiments. Stubblefield was just a farmer who would just find his way down to the local railroad station.
Guys, chat, sign lore. You see this picture right here? One day, when Sign has a little building, we're gonna make this picture again, but with all the modern day people that are doing like awesome work in the field. We're gonna copy this. So like Dr. Parkenstein, check him out on X. He built a magnifying transmitter, which is a Wardenclyffe tower basically, and sent power like hundreds of miles to his friend's property. So he would be in here, Joel Legacy, check out Joel Legacy, Lagace, genius. That dude needs to be in here. So yeah, we got to find, what is there, 14? I see 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then there's a 1, 2, 3, 4 right there. So 14. And then, yeah, so we got about, look how many OGs there was. Look how many legends there was back in the day. Tesla went here. Tesla came here. So these people are cool. We got to do that again.
And read publications from Electrical Wireless. So he had no formal really background in electricity at all. And when you don't have the formal background, things work. In other words, here's a guy that invents an earth cell, lights carbon arc lights, runs motors, has the telephone running on no energy whatsoever except for what's in the ground, and is doing this for miles. The technique was that the earth supplied all the energy that was needed. And since you're modulating the radiant energy, the voice appears at the other end. He did it by sticking 2 rods in the ground. And that powered his telephone. That was it. So he built a battery, what he called an earth battery, which was copper and iron wire. And he actually put this battery in the ground, and he used that as the source for his telephone system. So 1 earth battery at this end, 1 earth battery at that end, right? But you see Stubblefield in the pictures and everything as, here's his earth battery, here's his transmitter, okay? And his kids, he's out, a mile out, he sticks 2 rods into the ground. The guy picks the receiver up, and there's his kid playing the harmonica on it. Now, where'd the energy come from? They were using carbon microphones, and they were using, induction coils as a transformer, and real simple stuff. I mean, the guy had a telephone system that virtually was.
You guys, you got to think about this, okay? Everyone's like, oh man, even when what Tom Bearden said, you need $9 million, you need all this stuff. Okay, did you just see what they had? You think they spent $9 million on that? But the proof of concept is there, you guys. And that's what we need. We need to get over all this arguing and all this doubt, because look at what they did this with back then, and they couldn't order it on Amazon or anything. It's crazy, man. We have it good. You don't need $9 million to have fun in this arena and learn. You don't.
And real simple stuff. I mean, the guy had a telephone system that virtually was penniless to operate. Shame on you, right? We can't charge you. So therefore, let's get rid of this telephone system. The guy, from what I understood about everything that I researched on him, he had a way of detecting if you were coming through his cornfield. He knew exactly what direction you were coming from. Now, what science is there that allows you to do that today besides the science of our technology, which is, gee, you want to see the guy coming through the cornfield? Here's an infrared camera. but it's using a battery and wasting energy. Stubblefields didn't do that. Just a little ball swung in the direction the guy was coming from. Did it all by itself. Oh, this is in the 1800s, around the time of Tesla. Tesla standing in the picture is.
In the 1800s, he used a swinging ball to do the equivalent of infrared and see who is coming through his cornfield.
Why is he standing there? Why is he at this demonstration? The thing is, later on, Tesla develops the term radiant energy. So did Stubblefield stumble upon something that absolutely had to be squashed right then and there because of the phone system? Remember, we had the telephone. We had the telegraph. Look at the telegraph systems. Copper and zinc plates in the ground, one overhead wire, and they magically powered themselves for years. And sometimes, at the right moments, the telegraph operators.
Guys, new idea. Put a telegraph on the sign campus property. Did you hear that? Just zinc. What do you say? Copper and zinc plates and a wire overhead, and then now you have a on-land communication system.
Perfect.
Cool.
Could be electrocuted by the jolts that came off these things. Look at Miyuchi before this. Miyuchi develops radiant generators where he gathers the energy right out of the air by a process of coating his wires. And the only reason Miyuchi develops this is he had to keep in communications with his wife because she was sick. She couldn't get around, so he develops a telephone system before Bell. Through the ground, through the wires.
Happy wife, happy life, am I right?
Right? Earth batteries, just big plates, powering this telephone system that he kept in communications with his wife. Was an excellent chemist. Develops a coating for a wire that he strung outside in the air, and it gathers the energy in the form of electricity. Tesla's not in this picture standing with the whole gang, including George Westinghouse, for no reason. They're all there present in the picture. And
Chat. He said he coated a wire, which then would gather ambient energy. What if the coating material is in frequency with the Earth's Schumann resonance?
Fractal materials.
About this is this guy's a farmer. This guy's a farmer, and he only knows what was the proposed theory at the time. And he was interested in electricity because, now see, there's two different things here. You see, we got to define the electricity. Stubblefield's electricity was radiant or etheric electricity. There was no form of current in Stubblefield's electricity. You never see in any of Stubblefield's demonstrations a current meter because there is no current. Negative energy is radiant. You know, when he talks about negative energy, he's talking about energy that's opposite of the energy we know. These are all negative energies as far as the energy that we have. There's no mysticism here. Negative energy is radiant energy, or what Tesla termed as radiant energy.
So one of the problems that I realized that I'm still coming to terms with, but I think I do understand it. We've been thinking of energy, electricity, as one thing, just electricity. But there's two electricities. There's like positive electricity, which we have in our circuits right now. It's sort of above the equilibrium. And there's negative electricity, which is represented by the kickback EMF. So when you look at the kickback EMF, it has no current, no amps, but it has voltage, and voltage has a radiant field. Well, also, when you look at the kickback EMF, there are things you could do with certain materials where you only put a little bit of input voltage and the kickback EMF is higher, but it has no amperage. But if you can capture that radiant field and send it to a capacitor, then you could dump it with amperage. And yeah, I think that was the end of my thought.
I can see that. Yeah.
Or what is termed energy from the vacuum.
John got into radiant energy. He got in eventually into Stubblefield's work, and he was the only person I know of.
One more comment on that. When John Bedini, who was just talking, worked with negative energy, he reported that it was cold. And we know for every action or thing or whatever, there's an equal and opposite reaction. So if positive energy is hot, then interacting with negative energy should be cold. And what we notice in a lot, especially like these magnet motor generators and stuff like that, they'll start to produce an air conditioning effect, and they'll actually start to pull heat out of the environment and they'll get frost like ice on them. And those are probably interacting with the negative energy, which is actually the energy from the vacuum. That's what it is. And the 0 point is that point right before you cross down into the quantum, into that negative energy. That's what that is. So the 0 point energy is you're breaking that membrane and pulling in this negative energy now.
To this day, I'm not saying somebody else may not have done it. I'm saying he's the only one I know of that actually replicated Stubblefield's work. And that is something else, because Stubblefield was a phenomenon. And John uses the same term for that part of it as Tesla did. He calls it radiant energy, just like Tesla did in his radiant energy patents. And what he means by the term radiant energy is a combination of energy while it's still in the primary state in space, hasn't interacted with charge or mass yet. And he's also including negative energy in it. It can be either positive or negative. His term radiant energy actually means precursor state energy. The same thing the Russians went to their great system and classified so high in energetics, you see. He's doing Russian energy.
Yo, chat, look at this. Tom Bearden, Lieutenant Colonel Tom Bearden, presented this to the Army in a PowerPoint presentation. And I have some of his videos. I don't know if I have this one, but I have all the slides. Look at what this says. In the 90s, what year is on this? Sorry, the YouTube. It says 1996, T.E. Bearden, Subdivisions of Russian Energetics Technology. Just take a second and read this, chat. Okay, Lieutenant Colonel Tom Bearden was showing this to the Army. And then read these. In 1996, and then read these.
Yeah, scalar interferometry. Dan Winter uses that a lot, the terminology.
Energetics on the bench is what he's doing, but completely independently with his own discoveries. So when he uses the term radiant energy, and I'm using radiant energy, that's what he's using. He's using the next step just past what we're doing in electrical engineering.
In other words, it doesn't follow our conventional science. It can go through things that are dielectrics. Instead of wires, it may appear in a dielectric. It can melt plastic. It can use plastic as the conductor.
That's another thing that he found. When he was trying to send this current back into a battery to charge it, which is the back EMF or the negative energy, it would conduct through the plastic casing of the battery. And we'll see that in future videos. We're going to show it. Another thing I want you to see that's really cool. Okay, when you look at lightning, right, it's more of like a blue-white, like a blue-purple-white. I think most people would agree that lightning's like a blue-purple-white most of the time. Look at the color of this negative energy arc.
Conductor. Sure.
It's teal.
Yeah,
It's a totally different color than lightning. Or when you arc, or a spark in a spark plug, or anything. Without any gas or anything like that. In oxygen, it's teal. Interesting.
Stubblefield was able to take the energy out, and he was able to cause this energy to light the sky around his place, illuminate the trees. The light would originate in the ground, and the ground would radiate. And when he died, vans and folks came up to his small place, and everything in there electronic looking got moved out of there and taken. So they buried that one when Stubblefield died. Then you had Tesla. You had several other people obscurely between Tesla and Moray. The next one of great magnitude that really made the papers and all is, I think, Moray, although you can find a couple of others in there too if you look. And a succession of people came along who found different ways to extract the energy from the vacuum or to take it from the background potential, whatever you want to call it. And in every case, they were suppressed. T. Henry
Okay, he's going to talk about it. Never mind, I'll let him do it.
Morey was inspired, of course, by Tesla's work, and he demonstrated so many times to so many scientific and engineering groups and people who were skilled in the art. There is absolutely no question that T. Henry Morey had a system that produced about 50 kilowatts out of a 55-pound box. This is well established as you go back and look at all kind of certified tests and everything else that he did. There's all kinds of skullduggery that happened there. I don't think T. Henry Morey ever got a decent chance to ever do anything with that. The Russians even tried to kidnap him at one time. It reads like a James Bond movie, but it's real. It really happened, and it really happened here in the United States. This was before the war.
Wow.
This was in the 1930s. In the same general period of time, one of the greatest electromagnetic fellows we ever had, scientist, was Gabriel Krohn. And Gabriel Krohn invented a true negative resistor working on a Navy contract for Stanford University. He was never permitted to reveal the exact way that he constructed his negative resistor. But I used direct quotes where he, in fact, said, we have a negative resistor and we can disconnect the generator from this network analyzer when we got negative resistors in there because they will power the circuit. So that one was, in fact, suppressed. I don't know whatever happened to it, but it vanished. And he never did reveal the secret of what he called his open path, connecting any 2 points in a circuit. But it is in the literature and it's well documented because he was perhaps the leading electrical scientist in the United States at that time. So there's another one that went down the tube. Various and sundry people have made casual ones from time to time over the years. I'd estimate probably 50 different inventors have casually invented something. Even if they didn't understand it, they did get it to go over unity. We're never able to get anything done with it most of the time.
Tom Bearden's knowledge, at least 50 inventors got some type of a device to go over unity or coefficient of performance greater than 1. More work out than work in. In 2007, that he could think of off the top of his head, there's 50.
They incurred a lot of enmity from the scientific community. Sometimes were really hounded, and sometimes were just very naive. Sometimes very naive. Some of them fell into arrangements with people who were interested in selling stock and didn't care where anything worked or not. And then we have had charlatans in the area. Probably the best documented scientifically over unity systems, self-running, self-powering systems, were developed by the Russians before World War II. It's in the French scientific literature, and it's also in the Russian scientific literature. The papers are there. I quote them in many of the things that I published. And you can go.
Anyone read that translation chat?
Check the papers. The theory is there. Many papers are published on this in the Russian scientific literature. They built what we call parametric oscillators. They have an oscillator going, and they change in the middle. They switch the actual inductance or capacitance or both of the things so that it becomes a self-oscillation device. And they reached, goodly power for those days, 50 and 100 kilowatt devices. They found they had to have nonlinear loads because if they used just a standard resistor linear type load, the thing would self-oscillate, and it had enough positive feedback, it would continue to build up and would eventually destroy itself. With a nonlinear load, it would reach a plateau and operate at that plateau. That work is well documented. I have no idea how that got suppressed. Probably.
So with the linear load, so if you just continuously drew a load, it would just continuously give out more and more and more power until it melted itself. So they had to put the equivalent of like a speed governor on a car. And they had to do that by making it a non-linear power draw. So like a on-off type power draw, or so much for this long, and then it turns off and then back on.
Once Russia was attacked in World War II, the war was so awesome and so terrible, so many casualties and so much massive effort by the Russians, I think it just got swamped out of there. But the work is still in the literature. You can check the papers, and they're for real. That's real work by real physicists in a couple of the leading institutes in Russia prior to the war. And there's quite a few of the papers in both the French scientific literature and the Russian scientific literature. Lethal force is used. I worked with an inventor, for example, the Sparky Sweet is quite well known. And he was shot at once with a silenced rifle a sniper rifle from about 300 yards. The only thing saved his life was he was an old guy and very feeble there towards that part of his life. And he was stumbling as he coming up the steps, and he fell down. He just flat fell down on the steps, caught his foot and fell right forward. And as his head went forward, the bullet went right by where his head was. And of course, the assassin was never found. So there are many cases like that. Some are killed. I believe Marinov,
You guys, the reason that they did that is because Floyd Sweet's vacuum toroid, I believe, amplifier Floyd Sweet VTA. Type that in. Research that. The coefficient of performance, or the Q value, was in the millions. And it was a small device, relatively. So if you put in 1 volt, you get out 1,000,000 volts. Forget 1 volt and you get 4. Insane stuff. And I don't think anyone knows exactly how his circuit worked, but I suspect it had to do with Gabriel Krone's work with negative resistors.
To be a kill. I don't believe Marinoff jumped off a building when he was excited on the way to talk about his invention and so forth. Gave no indications of it. If I can believe the reports of the people who visited where his body lay on the pavement glowed. And there's only one weapon on earth that will kill a human body.
We got to back this up, chat. This is a crazy story, and I was talking. I'm sorry.
Old guy and very feeble there towards that part of his life, and he was stumbling as he coming up the steps, and he fell down. He just flat fell down on the steps, caught his foot, and fell right forward. And as his head went forward, the bullet went right by where his head was. And of course, the assassin was never found. So there are many cases like that. Some are killed. I believe Marinoff, I believe to be a kill. I don't believe Marinoff jumped off a building when he was excited on the way to talk about his invention and so forth. Gave no indications of it. If I can believe the reports of the people who visited where his body lay on the pavement glowed. And there's only one weapon on earth that will kill a human body and leave where it lies on the cement, let the cement glow under it. And that's a longitudinal wave shooter, what's called a shooter. So I believe, my personal belief, I can't prove this in a court of law, I don't intend to try, but my personal belief is that Marinoff was killed. He was probably killed by either KGB or...
Chat, is he saying Marinoff? Do you guys know what that is? I don't think I've heard that name before. Probably too underground for like a quick search. I'm gonna look into that.
Or one of their agents from one of the other Iron Curtain countries killed with a shooter and thrown off the building to make it look like suicide. The police probably knew about it. That's why they let the body lay so long before they moved it. They didn't want to tangle with the longitudinal waves from it. So yes, there are some rather bizarre things that have occurred to some people.
There it is. Dr. Stephen Marinov, a former assistant physics professor at the University of Sofia, Bulgaria, was found dead by the fire escape from the library building at the University of Graz, Australia, on July 15, 1997. Did you hear how he died? It sounded like a Scooby-Doo episode.
I forget now what I was looking for that day, but the guy ended up wanting to know what I wanted to use it for, and it had to do with free energy. And so at that point, he says that he knew firsthand, this is the exact words, he knew firsthand that all the oil companies employ groups of engineers whose main task is to evaluate every energy-related idea they can find. And he said when they find one that they like, they will make the guy an offer. And their attitude is that usually the inventors are short of money. They like to invent, but they don't know how to make money. And so they'll typically offer them $40,000. If that's not enough money, they'll keep raising the offer until they find the guy's price. And then they will buy it, and then they will bury it. Now, just coincidentally, this one little machine that I personally tested that put out 4 watts of power, Don Maxwell is actually an inventor of that thing. Don lived in Dallas, Texas at the time that I met him. I've been working with him for quite a number of months, trying to build hardware for him and so forth. I get this phone call from him one night. He was very agitated or excited or whatever in this phone call. And he had just hung up the phone from talking to a guy who called him. And the guy said,
Chat, is he asleep? I'm sorry, man. You guys realize I put it on 2x speed? And
Yeah.
I feel like he's almost asleep, even at double speed. That's crazy.
Speed multiples are going to be a frequent thing on
we
this
know about
channel.
your device and we want to buy it. And the guy began to tell Don about everything they knew about it. The fact that he stored information on his computer and little details. Some of the details could have only been known to somebody who'd been listening to phone conversations between me and Don. They were just, we're just talking details about something. And then the guy went on to tell Don about several different inventors around the world who had devices. And in each case, the guy told Don how they intended to stop the use or continuing work on each one of these devices. He was very specifically, this guy by name. And they weren't just talking generic devices, they were talking name. So I listened to all this, and after we hang up, I sit down and I write down on a piece of paper everything that Don told me. And then I typed it up, sent it off to him, and said, is this what you said? And he only changed a couple words. And so the only thing that I could think of to do at that point was to send everybody whose name was mentioned a copy of this as a, hey guys, heads up, you know. Well, it turns out that I knew who all these people were. Well, the guy that told me about this first person has visited this guy's house and learned how to build these things from him and was in the process of building them. Well, it was the second person whose name was told to my friend Don is the person they were going to stop. And the way they were going to stop that project is they would place something near where the machine was that would cause the machine to not operate when he wanted it to operate.
So you could have like a free energy device, and then you could like book a hotel tour, and like the one consistent guest that you think is like your best buddy, his like Powerade bottle has like some crazy electrolyte thing in it, and it like makes your thing not work, and he sabotages your whole tour. Like something like that is what he was basically saying. He said someone brought a thing that when he would put it by the device, it would make it not work. That's how they sabotage that guy.
This is early 70s. By this time, he had built EMA4. EMA4 was a full-size power plant, 80 horsepower on the dynamometer, sitting on the rack. He would quite often show it with an automobile transmission bolted to the back of it. It ran on 4 large storage cells, which the system would keep fully charged at all times. So he had come a long way. He was clearly demonstrating a form of energy which you can't fake easily by lighting light bulbs underwater without being shocked. He was showing a dramatic gain in mechanical energy derived from his circuit motor combination. And he was giving demonstrations, and people were giving him good press. In 1974, about a year after all this good press.
You see that? What the heck?
That's one hell of a demo.
I'm assuming there's rotating magnets in this thing. And that's all I know about it. I don't even know that.
In 1974, about a year after all this good press started happening, for no reason that can be traced to any inappropriate activities by Gray from a business point of view, the Los Angeles District Attorney's Office raids his lab. They pack up all his business records, they pack up all his working models, and take it away, haul it away. They spent the next 8 months contacting all of his stockholders and everybody, trying to get them to file charges for fraud against Gray, because obviously he was demonstrating something that just the laws of physics says impossible. Obviously he's cheating you. None of them would press charges. So in other words, when the DA went into the office, they didn't have a case against him. They had no one who had filed a complaint. They had a warrant, but they had no complaint. To this day, no one.
You guys, in America, with no pre-prompted complaint that's publicly known, a judge issued a warrant to a random inventor. They invaded his space, his home, confiscated all of his stuff, then brought up a case against him for fraud, but there were no complaints.
Knows what initiated the raid, because no one who was a stockholder or involved in the business in any way filed a complaint. In other words, as it's stated in the articles, the LA District Attorney's Office acted unprovoked. At the 8-month point, they could.
Who told the state to do that? Like, was he at a donut shop and he like accidentally told a cop like his invention, and they were like, "Oh, that's scary," and then like, or did that not happen and somebody else told the state? Like, who told the state? And then also, you need evidence and probable cause to get a warrant. Most of the time, judges can, just do what they want sometimes, but it won't hold up in court by the time you get there, just like this. So who said that?
Get no one to even file a complaint to back up their case, at which point they charged Gray with fraud and grand theft. But they had no evidence to support it, and ultimately those charges fell away too. But not before a lot of time was lost and a lot of money was spent defending yourself against this nonsense. Ultimately, the end of this witch hunt found a number of minor SEC violations. He paid a fine, and the case was dropped. After the charges
So I haven't been able to hear Aaron for a while since we had some technical difficulties. Do you want to say anything, man? Because I think it is coming through the stream, and then just give me a thumbs up when you're done.
Oh yeah, that'll work. Yeah, no, so it is funny that we can't hear each other. Yeah, no, I've been clicking in trying to like overlay what you've been saying before. So yeah, we'll figure it out. This stream's done. This is our first stream, by the way, guys. So there's going to be many more in the days ahead. We're going to do live streams of multiple episodes on Mondays. Normally, we just started this week on Tuesday, and then we're going to cut those up into individual episodes. We'll upload onto the various platforms: YouTube, Rumble, and Twitch right now. So. Thanks for being here with us. We've had as many as 5 viewers, and we super appreciate your comments. Will show up on screen, and we'll interact with you guys as well. So thank you for being with us. Oh, I just put my
Were
thumb
dropped.
up. Oh, good.
And the criminal case was dispatched. Gray was never able to get any of his business records or any of the working prototypes back from the DA's office. None of his personal property, corporate property, was ever returned.
There's even a little evidence, and I don't know really how to put this in perspective. We had one friend, for example.
So even though they charged him and there was no evidence, they still never returned any of his belongings.
That we worked with very closely, who built practical over Unity systems. He demonstrated at a conference, for example, an 8-kilowatt system. And then very mysteriously, he and his whole family disappeared. We have found out since, in fact, not long ago, that he's still around, and he's doing very well because he was attired in a very expensive suit and a very nice automobile. But he and his family are okay, even though they disappeared back there. But here was a successful unit that just flat disappeared off the face of the earth. Now, I assume, rightly or wrongly, it has to either be for the great financial empires, or it has to be for some kind of black project that somebody needed a power system that would power itself in the load. And they classified it. Whatever it is, I don't know. But whatever it is, the survival of humanity itself and civilization itself is now at stake. And I really believe through the auspices of the U.S.
In 2007, Tom Bearden really believed that sort of the survival of the human race was at stake. 2 decades ago, Lieutenant Colonel Tom Bearden thought that. And we're still in the same position right now, like we're in kindergarten class reviewing it. We're in kindergarten reviewing that humanity is like screwed. 20 years after he said it was already screwed.
Basically.
You see how much catching up we have to do. So, in light of that, Sign has created a petition called the Demand Access to Advanced Renewable Energy Technologies, or the DART petition. It's on change.org at change.org/clean energy for all. And you just fill in your email and you can sign that petition. And what that petition is doing is we're gaining steam to be able to pressure politicians, institutions, corporations into revealing some of this information. There are modalities you can do. There are declassification reviews you can do. There are a lot of different steps we can take. And if we have 100, 1,000, 10,000, a million signatures all on this one petition, when we write these letters to these people, that's a lot of force behind it. You know, it's not just Joe Schmo. So if you visit change.org/clean energy for all, that is Sign's initiative to go ahead and start doing something about this, because I think we're about 20 years behind, at least.
Government, regardless of what that kind of program in it anywhere may have, we must bring it forward to save ourselves and save the earth. If we don't, we can keep it secret, or we can keep it in the control group hands, and we shall all go down to oblivion. I prefer not to dwell on that, try to get by as much of that as we can and try to dwell on the science. The only way we're ever going to beat all of this stuff, we have to convince the scientific community that there's real science here. It's really a good theory. It doesn't violate physics. It doesn't violate thermodynamics. And it's experimentally proven. And this is the thing we have to concentrate on and get through. Because if we ever get the scientific community turning those young grad students loose, they can plot and scheme all they wish to. It'll roll over them just like a steamroller. And that's what we've got to get going.
In September 2005, Tom Bearden received the following letter from Michael Reichman, Deputy Assistant Director at the National Science Foundation in Arlington, Virginia. All right, I'm going to pause it there so you can like pause it also and try to read that. It's a little blurry. And you know what? I think I actually have a copy of that letter in the signed files. So if I do, we'll get it uploaded and we'll get it linked into the YouTube video once this is edited down here in about a week or so. There is a uniform support for your out-of-the-box thinking about conventional models and mathematical approaches. That's what they had to say about Lieutenant Colonel Tom Bearden here. I don't know. I think this guy's goated, chat. I don't know. I think this guy might be like Hal Puthoff, but good. You know, if he was still here, I think. Late in the year 2000, on the eve of a briefing appearance in Washington, D.C., before Senate congressional staff, members of the Energy Committee, Tom Bearden had the following to say.
We're trying to communicate the truth as fast as we can, as massively as we can. And that's the best we can do, unless we can get the government to move. If we can get the government to move, they can cut through all of that by simply issuing the order to do it. And that's what it's going to take. Well, not just us. There are several other inventors and groups.
I don't think the government's going to move, but if we have 1 million signatures on the change.org/clean energy for all petition, maybe you can pressure certain politicians into it. But I do think the institutions and the corporations are going to be a little easier to crack, actually.
In the same area and have systems that work. We are not the Lone Ranger here at all. I want every system out there that works and real going. We need everything we can do. Now, that's my personal view. A lot of folks think that we're going to be able to just stagger on with the way we're going, polluting the whole planet, increasing the electrical demands everywhere. Everybody wants a modern life. They want to get out of the mud and the slime and everything and have lights and have, things that are powered and have industry and jobs and homes and schools. These are common strivings from the human heart. And to try to do that the way we're doing it will destroy the planet, and we will forcefully destroy each other. It seems to me we just ought to be wiser than that.
Late in his term, President Bush acknowledged the need to move beyond oil.
By applying the talent and technology of America, this country can dramatically improve our environment, move beyond a petroleum.
Hey, I haven't seen him in a hot minute. What about you, Chad? You guys seen George W. Bush?
Junior himself.
Oh, man, we need to update this, guys. This needs a major update. Also, Chris Zazula said, suggestion, the theme song from the movie Weird Science. Yeah, pin that. Great movie.
Petroleum-based economy and make our dependence on Middle Eastern oil a thing of the past.
All right, chat. That was legit. Let me turn this down. All right. All right. Thank you for joining us today at the Sign Academy. Aaron has joined me today. My name is Rob. And that concludes the review of the Energy from the Vacuum Part 1 overview. This is the second half. The first half was recorded onto the Twitch channel, and it will be edited down and put on the YouTube channel eventually. Unfortunately, we had a technical glitch, and I can't hear Aaron, but I'm going to let Aaron say some stuff just to close this out real quick. And then he's going to give me a thumb up, and then I'm going to turn it off. And next time we'll do a little better. But thank you. I think we saw 5 people in here at one point or something. Plenty of people chatting. I feel like there were some good laughs and some good times and some good quotes. And there's only 43 more of these to go. All right, Aaron.
Yeah, like you said, we've got quite a few episodes to go through. We're getting on a regular schedule. We're going to be doing this on Mondays on the days ahead. If you stay up with the live streams, they're going to be up for a limited amount of time. They will be doing multiple episodes in a row, and then we're going to cut those down into individual episodes to release on their own. And then eventually removing the live stream. So if you want to stay up to date, the live stream is the way to do it, and then the subsequent episodes. So very excited to work with you guys. Make sure to check out the X pages. We'll get the links and stuff updated and everything on the YouTube. You can watch us YouTube, Twitch, Rumble. We're going to have everything simultaneously from there. Eventually, we're going to also be simulcasting into X Spaces and Telegram as well. So we should have multiple platforms to be able to put this out and just to expand the discussion and awareness of this science and these realities, while also doing practical application in the days ahead. So thank you for joining us, and we'll catch you guys on the next one. All done, Rob. You can end it whenever, even they can't hear me. Let's go.
All right, guys, we'll let this play out. 3 more seconds. Bang.
And to with that spark, that's awesome.
And you wish you could see Energy from the Vacuum Part 2. That's for next time. See you guys later.